the simple trick that turns a lemon into a battery.
Hello? Is anyone there? It's awfully dark in here. Did I fall asleep? Did the power go out? I'm serious. I can't even see my own glass. 1 minute I'm part of the family, the next, I'm just a glass ball hanging in the dark. Let's think about this logically. I'm fine. I checked my reflection earlier. My glass isn't cracked. My filament, that tiny wire inside me, is sitting right where it should be. So why am I still dark? It's because something invisible, something vital didn't reach me. Whether you're a student deep in exam preparation or just someone who hates sitting in the dark, you've probably asked, what is electricity? And more importantly, where did mine go? You see, electricity isn't like magic. It doesn't just appear because you want it to. It's a traveler. It needs a road, a map, and a destination. When the road is blocked, the light disappears. This is the big secret behind electricity and circuits. To find out why I'm dark, we have to trace the path from the very beginning. Think about where you get your energy. For your whole house, the fridge, the TV, the AC, electricity comes from massive power stations. They send power through miles of heavy wires. But what about when you're building school projects at your desk? You can't plug a cardboard model into a wall socket. That's when you need a pocket-sized power station. We call it the electric cell. Look at this little guy. It's simple, right? But inside, it's a chemistry lab. One end has a metal cap. That's the positive terminal, plus. The other end has a flat metal disc, the negative terminal, minus. Inside, chemicals are having a reaction, turning chemical energy into electrical energy. But remember, it has a limited supply. When those chemicals are all used up, the cell goes dead. Now, don't think you need a factory to make a cell. Later on, I'm going to show you a simple circuit experiment where a piece of fruit, yes, a literal lemon, acts as my power source. You're gonna want to show your teachers and parents this. A light bulb powered by a salad ingredient, so stay tuned. Not all cells are the same. Some are use and throw. You put them in your TV remote, use them until they're empty, and then buy new ones. These are primary cells. But then you have the heavy hitters, like the ones in your phone. You use them, they get empty, you plug them in, and they're ready to go again. These are secondary cells, rechargeable. And if you join two or more together, now you've officially built a battery. Let's talk about me for a second. How do I glow? If you look through my glass, you'll see two thick wires holding up a tiny coiled up thread. That's the filament. When electricity flows through that filament, it doesn't have an easy ride. The wire is so thin that the electricity struggles to pass through. It gets hot, really hot, so hot that it starts to glow bright. I always say, light is just heat with confidence. But here is the catch. Electricity is picky. It won't move unless it can go in a full circle. If you connect a wire from the battery to me, but don't connect me back to the battery, nothing. It's like a bridge that stops halfway across a river. That complete, unbroken loop, that is an electric circuit. If there's a gap anywhere, the traffic stops and I stay dark. This is my biggest fear. Sometimes the circuit is perfect, but I'm still dark. Why? Look at my filament. If that tiny wire snaps, the bridge inside me is gone. I'm not being lazy, I'm fused. A fused bulb has a broken path and no amount of electricity can fix it. You don't want your lights on 24/7, but pulling wires out of a battery is messy. That's why we use a switch. Think of it as a gate. When the switch is on, the gate is closed. The path is complete. When it's off, the gate is open, creating a gap. This is a favorite project for Class 6 students to build. Electricity has favorites. Let's test some. In iron key. Oh, I love that. Metal is a conductor. It lets electricity slide right through. A plastic ruler? Nothing. That's an insulator. It blocks the path. This is why wires are made of copper metal on the inside, but wrapped in plastic on the outside. Metal carries the power, plastic keeps you safe. Speaking of safety, electricity is powerful. We use insulators like rubber gloves to stay safe. But what about your house? If too much power rushes in, it could fry everything. That's why we have the fuse. It's a tiny wire that melts and breaks the circuit if it gets too hot, saving your home from a fire. It's like a secret bodyguard. Real circuits can look like a bowl of messy noodles. That's why engineers use symbols. Instead of drawing a real bulb, we use a circle with a loop. Instead of a battery, we use lines. It's a shortcut that makes exam preparation way faster. Time for the lemon battery. We roll the lemon to get the juice moving. We stick in a shiny iron nail and a copper wire, connect them to me, and look at that! It's not very bright, but it's real science. The acid in the lemon reacts with the metals to create a flow. Even a fruit can be a power station. See? I wasn't broken. I just needed my path fixed. Before you go, remember, you need a source, a closed circuit, and the right conductors. Keep the path clear, and I'll always shine for you. Tell me in the comments, what's the weirdest thing you've tried to use as a conductor? Ever used a potato? Now that you've mastered the internal world of circuits, are you ready to see how my light interacts with the external world? If you want to know how my light creates shadows or why you can see yourself in a mirror, you need to check out our deep dive into NCERT Class 6 Science, Light, Shadows, and Reflections video.
Scan the QR code to download our app, practice maths, science, English, and more. Like the video and subscribe our channel for more fun videos.